Hey guys, welcome back to the video. Today we'll be talking about the Bohr-Rutherford diagram and the Lewis dot diagram for fluorine. First, I will be talking about the Bohr-Rutherford diagram, then I will be getting into the Lewis dot diagram. So the Bohr-Rutherford diagram has a nucleus which has two subatomic particles, the number of protons and the number of neutrons, and it is surrounded by these rings called shells. Within these shells, there are certain rules to follow. For example, the first shell should contain 2 electrons, the second shell should contain 8 electrons, and the third shell should also contain up to 8 electrons. These diagrams should look like planets orbiting the sun. Although Bohr-Rutherford diagram was helpful to understand how electrons orbit the nucleus stably, it has major problems. One of the problems is that it states electrons has known radius and orbit. This breaks the Heisenberg's uncertainty principle, thus it is considered to be incorrect. The Bohr-Rutherford diagram was invented in March 6, 1913 by Niels Bohr. Next, we'll be getting into the Lewis dot diagram, which is actually one of the special diagrams comparing with the Bohr-Rutherford diagram. The Lewis dot diagram was created to represent the number of valence electrons of an atom within a molecule. The Lewis dot diagram was extremely helpful, and by learning the diagram can help one find the reactability of a molecule and the interaction with other molecules that is presented. The diagram consisted of two main things, the number of valence electrons and the element symbol. The valence electrons were shaped like a dot which surrounded the element symbol. So the finding of the valence electrons are pretty simple. It could be found within the groups. So for example, fluorine is found in group number 17, which means that it has a valence number of 7. It is also the outer layer shell of the Bohr-Rutherford diagram, so the last shell or the last ring of a Bohr-Rutherford diagram. And finally, the Lewis dot diagram was invented in 1916 by Gilbert Lewis. Before we get started with our drawings of Bohr-Rutherford diagram and the Lewis dot diagram, we need to understand certain things, so it might be helpful with drawing the diagrams. So the number of neutrons and the number of protons are the subatomic particles within the nucleus, or you could call it the brain of the atom. The atomic number, which is equivalent to the number of protons, defines what an element is. For example, an element has 9 protons, it is fluorine, and if it has 5, it's considered to be carbon. This also helps provide the identity of an atom. Since we're on the topic of fluorine, why not get a quick fact about it? Fluorine is the most reactive substance in the periodic table, and it attracts electrons easily. With this in mind, let's get into the video in 3, 2, 1. Hello everyone, today I'll be talking about or teaching you guys how to draw the Bohr-Rutherford diagram and the Lewis dot diagram for fluorine. So before that, we need some things or essential things in order to draw these both diagrams. So we need to look at the group number and the period for fluorine. Fluorine falls under a group called halogens, so group number 17, which are highly reactive, and fluorine is gas at room temperatures. And it is period number 2 or row number 2. The number of periods also represents the number of shell an element has. So for fluorine is 2. Okay. So there's 2. So these are the shells. So there's 1, 2, and this is a nucleus. The shells are always orbited by the number of electrons, and there should be the number of protons and the number of neutrons in the center or inside the nucleus. So the number of protons are obviously positive, the electrons are negative, and the neutrons are neutral, so no charge. So in order to find the number of protons, it's the same as atomic number for fluorine, or an element. For fluorine, there's 9, so the number of protons is also 9. The number of electrons is same as the number of protons, so it's also 9. And the number of neutrons is by subtracting the atomic mass by the atomic number. So 19 subtracted by 9 is 10. So there will be 10 neutrons. for fluorine. So inside the nucleus, we need the number of protons and the number of neutrons. So there will be 9 protons, which are positive, and there will be 10 neutrons, which will be neutral and has no charge. So this is our nucleus of fluorine. Okay, and let's get started with our shell. So for a shell, it's pretty easy. It is just the number of electrons. So for fluorine, there's 9. So there should be 9. And for the second shell, you should go by clockwise to ensure that you're doing it right. So it should be like this. So 1, 2, 3, 4, 5, 6. So now we have single electrons. We can now pair them. So we have 6 so far. 7, 8, 9. So there's only 9 because there's only 9 electrons for fluorine. So this is how your Bohr-Rutherford diagram should look like. And some key notes to look for is there's no bonding between these electrons. So you shouldn't draw them very close to each other. So it should be like that. And it should orbit the shells. And it should be looking like planets orbiting the sun. Okay, so this is our Bohr-Rutherford diagram for fluorine. Now let's get started with our Lewis dot diagram. For our Lewis dot diagram, we need the symbol or the element symbol and the valence number. So let's draw the symbol first. Now we'll be explaining how to find the valence number or the valence electrons by 2 ways. So fluorine's symbol is F. So let's get into how to find these valence electrons. So the valence electrons are the group number. So for fluorine is 17, which means that there's 7 valence electrons. For example, or for oxygen there will be 6. For nitrogen it will be 5. For carbon it will be 4. For boron it will be 3. So since we're doing fluorine, there's only 7 valence electrons. So this is one way of finding it. The another way is by looking at the Bohr-Rutherford diagram. The outer layer shell is always the number of valence electrons. So there's 1, 2, 3, 4, 5, 6, 7. So fluorine has 7 valence electrons. Okay, so let's get started. And also go clockwise to ensure that you're doing it correctly. So 1, 2, 3, 4, 5, 6, and 7. So this is how your Lewis dot diagram should look like. It shouldn't have any bonding between each other. So it should look like something like that. So let's summarize what we learned so far. So this is how your Bohr-Rutherford and Lewis dot diagram should look like for fluorine. So for the number of protons, it's the same as the atomic number. The number of electrons is the same as the number of protons. The number of neutrons is by subtracting the atomic mass by the atomic number. So 19 subtracted by 9 is 10. And neutrons are always neutral, so no charge. Electrons are negative, so right here a minus sign. And protons are positive, so plus sign. So the shell should contain the electrons, the number of electrons orbit the shells, and the nucleus should contain the number of protons and the number of neutrons. In this case, for fluorine, there's 9 protons and the 10 neutrons. Okay. For the Lewis dot diagram, it's the number of valence electrons. So there's 7 valence for fluorine. So 1, 2, 3, 4, 5, 6, 7. So this is how you draw the Lewis dot diagram. I'll also draw it again for you if to like draw bigger and for make it clear for some of you. So this is how this is the element symbol, and you should do 7. So 1, 2, 3, 4, 5, 6, and 7. So this is how it should look like. I drew with the pen so you can see it clearly. So there shouldn't be any bonding. So this is how you should draw the Bohr-Rutherford diagram and the Lewis dot diagram for fluorine. Thank you for listening to my presentation.